Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as assistant professor in Gokhale Education Society's Arts, Commerce, and Science College, Jawar, Palghar. Welcome in the lecture series on the new topic that is spectroscopy. As you know that spectroscopy is one of the very important topic in the organic chemistry, where basically we try to study the molecular or structural analysis of organic compounds. So this particular topic is being having different study of spectroscopy techniques such as ultraviolet radiation and mass spectroscopy for this particular term. So we'll try to revise some of the concepts. Basically, if we ask the question, what is basically the spectroscopy? As already I had told you, it is a structural analysis of the compound. But what exactly happens? If we try to elaborate the term spectroscopy, it is nothing but the study of interaction between matter and electromagnetic radiation. So it is an interaction between matter and electromagnetic radiation. Or in another terms, what we also can say that in spectroscopy we basically study the response given by the molecule when it is exposed to electromagnetic radiation. So that particular response will be determined in terms of spectral data. That may be a spectra, or you will get some terms, so that will help to understand the structure. So basically remember, it is an interaction between matter and electromagnetic radiation. So we can also say that a spectroscopy is the method which is based upon the interaction, absorption and production of light by matter. As we know that matter consists of molecules, and molecules may have electrons, nucleus, subatomic particles, and which constitutes. So whenever that particular matter is exposed to high energy electromagnetic radiation, there occur some changes, and these changes are recorded in the form of spectra. Okay, so based upon this particular basic information, we try to understand what is basically electromagnetic radiation. As we know that electromagnetic radiation is nothing but a source of energy which interacts with the matter, and that particular electromagnetic radiation has a form of light, and we know that light is always travel in the form of wave in the medium. So if we consider what is a wave model for that particular light propagation, so this particular graph we can say the wave always travel in the form of sinusoidal pattern. So it has this particular pattern. If you try to elaborate the term electromagnetic radiation, so what is electromagnetic radiation? It consists of two components. One is electric component and another is magnetic component, and both these electric and magnetic component always oscillate perpendicular to each other and perpendicular to the propagation. So remember, there are two components which always travel perpendicular to the each other. So this is a wave model. Always remember that whatever the electromagnetic radiation, they always travel in the form of wave. And if we consider what are the different components of this particular wave, let us see. As already I have told you, wave model is the sinusoidal wave which travels in a space with an oscillating electric and perpendicular magnetic field. So remember this particular wave model. So in order to understand some of the spectroscopic techniques, some terms must be clear. So here I will like to clear some of the terms, such as first term is amplitude. Already I told you the electromagnetic radiation travels in the form of wave. So if you can say this particular wave, it has this particular point. It is being called as a crest or top of the wave. Again, this particular wave travels in the minus part, you will have this particular part that is being called as a trough. So one crest and one trough completes one particular cycle. So if we see what is meant by amplitude of this particular wave. So amplitude is this much distance from 0 to up to this one. So as the amplitude is more, you can say this particular distance will be more. So amplitude is distance from 0 up to the highest point of that particular wave. That may be in the upper side or in the lower side. So remember, we can say amplitude is nothing but the maximum height of wave. So this is a height of wave, remember. Then second part we will try to understand what is meant by wavelength. So if you can see here, wavelength is the distance between two identical points, or we can say wavelength is the distance between two successive crests or two successive troughs. Troughs is the lower part, crest is the upper part. So this particular distance is called as a wavelength. Okay, so wavelength is the distance between two maxima or two minima. So how we can explain wavelength? So this is the distance between two identical points. Then another term called as a wave number. So if you want to understand what is wave number, it is denoted by the sign nu. It is slightly displaced, let us understand. Nu. So wave number. So wave number, if we consider suppose a portion of, let us say, 1 centimeter on this particular plot. So in that particular 1 centimeter plot, how many waves passed from that particular 1 centimeter area is called as a wave number. And this particular wave number is the reciprocal of wavelength. If you have lesser wavelength, then you can have the wave number will be greater. If you have the more wavelength, then wave number will be lesser. So we can say wave number and wavelength, they are reciprocals of one another. I will explain again what is meant by wave number. It is a number, so it is related with the area. So if we consider this particular area, let us say this is a 1 centimeter area. From that 1 centimeter area, how many cycles passed is equal to the wave number. Okay, so this is how we can consider. So always remember, wave number and wavelength, they are reciprocals of one another. Then another term, fourth term, that is frequency. So what is meant by frequency? It is the number of cycles which passed from a fixed point in a space per second. Suppose if we consider this particular point. So from this point, how many cycles passed per second? That will be related with the frequency. So remember, these are the terms which will help to understand the next terms related with the spectroscopy: amplitude, wavelength, wave number, and frequency. Now we will try to understand what is basically electromagnetic spectrum. So already I explained you, electromagnetic spectrum or radiant energy, it always travels in the form of wave, and it is believed that radiant energy is emitted by fluctuation of electric charge and magnetic field. As this particular electromagnetic spectrum, it can have the different sections in that particular spectrum depending upon the frequency of that particular radiation. So this particular electromagnetic spectrum can have the radiation from ultraviolet region to infrared region, from in the X-ray region, radio waves region, microwave region. So these are the different sections you will observe based upon the frequency of radiant energy. So in the electromagnetic radiation, we can arrange the types of electromagnetic radiation in the order of increasing wavelength or decreasing frequency, is known as complete electromagnetic spectrum. So in the electromagnetic spectrum, we can arrange the electromagnetic radiation depending upon increasing wavelength or in the term of decreasing frequency. So we can have this particular. So this is a we can, in short, we can distribute the electromagnetic spectrum, and on this particular electromagnetic spectrum you can have the radiant energy from higher wavelength to lower wavelength. Already I explained how to, from this particular wave or from this particular pattern, how we can understand which wavelength is greater and which wavelength is lesser. You can see this wavelength is higher, this distance is higher. If you see here, this distance is lesser, so this is a higher wavelength, and this is a lower wavelength. In terms of frequency also, we can, higher the wavelength, lower is the frequency. So in the electromagnetic spectrum you can have the region of higher wavelength, that is microwaves, then comes radio waves, then comes infrared and visible region, which we can see with our naked eyes. So this is that particular region. If you go with decreasing wavelength, then ultraviolet, then comes X-ray, and then comes gamma rays. So gamma rays has very lower wavelength, so we can say lower the wavelength, maximum is the, or higher is the energy. Always remember longer wavelength. Here you can see the longer wavelength. Microwaves, radio waves having longer wavelength, so they are having lower energy. Gamma rays having shorter wavelength, they are having higher energy. So always remember these particular words with related with the energy. Now we will see the different regions which are there in the electromagnetic spectrum. So electromagnetic spectrum is the distribution of electromagnetic radiation according to energy. As we know that the energy, electromagnetic radiation travels with speed 3 into 10 raised to 8 per second. But you can have the velocity will be same, but there may be changes in the frequency and wavelength. So how we can distribute this electromagnetic spectrum? Let us see. Over. So here you can have the distribution in terms of frequency. The frequency you can measure in terms of hertz. Wavelength you can measure in different units: nanometer, microns, Armstrong unit, centimeter. So this is the wavelength. Lower wavelength, higher wavelength. Okay, and in terms of energy. But remember always, your electromagnetic spectrum will have different sections depending upon the electromagnetic radiations which are irradiated on that particular matter. So gamma rays are due to the nuclear excitations. In the case of positron emission tomography, this particular gamma rays are being used. X-rays, in X-rays we basically try to understand the core structure of the matter. So X-ray crystallography, where we understand the X-rays. In UV, ultraviolet, where you can observe the electronic excitations, where generally the valence electrons involved. In IR spectroscopy, then in microwave and in radio. In NMR we use radio waves. So here we can say, here in case of the radio waves, wavelength is longer the wavelength, shorter is the frequency, and greater is the longer is the wavelength, shorter is the energy, and greater will be the frequency. So here you can see this, remember this particular pattern. So these are the different electromagnetic regions you will observe in the case of the electromagnetic spectrum. So now we will try to understand the next term that is being called as a quantization of energy. As I already told you, whatever the light energy, it always travels in the form of waves. It has been earlier assumed that particular light, let it be absorbed or in the emitted form, it is observed continuously. But in 19th century, a great scientist Planck has explained that particular absorbed energy or emitted energy that is not being a continuous, but it is in the discontinuous form, and it is always being given in the form of packets, that is being called as a quanta is the form of packets means suppose that particular energy is irradiated in the form of some number, for example 100, 200, 300, 400. So you will observe continuous pattern. So remember always, the quantization of energy is related with the quanta, and each quantum is called as a photon. So energy of that particular wave we can calculate with the help of formula H E is equal to h nu, where we can place the value of nu as a c upon lambda. So what happens whenever the energy irradiate on the matter, there occurs different changes in the matter. So if we consider the incident light comes on the matter, in the matter there is a molecules, so molecules are having some energy, and there occurs, due to the incident energy, there occurs the phenomena such as absorption, where the electrons are excited from the lower level to higher level of energy, or there may occurs the emission phenomena. So there occurs the absorption and emission of the phenomena, and you can calculate the transition energy, that is E2 minus E1 here we can calculate. So quantization of energy is the very important term we need to understand. It is in the form of discontinuous matter. Then we try to understand what is absorption phenomena. Already in the last slide we have seen the absorption phenomena. So what happens whenever any electromagnetic radiation of particular wavelength are passed through the substrate or matter, they undergo radiation of certain wavelength are absorbed by substrate. So we call it as a absorption energy, and some of them are transmitted. So they are absorbed wavelength we can analyze. So the wavelength which is being absorbed is characteristics of some particular functional group which are present in the compound. So whatever the absorbed energy that directly correlated with the molecular structure, whatever the functional group we are having, what are the different types of electron you are having, that energy will vary. So you will, based upon that functional group present in the molecule, you will get some pattern in the spectra, and whatever the energy is absorbed, that is called as a absorption spectra. So after the absorption, whatever the remaining energy, that will be transmitted, and that transmitted energy will be analyzed with the help of spectrometer. So absorption spectra results due to the electronic excitations of electrons from lower energy to higher energy levels. So this is a expected phenomena you will observe in case of the absorption spectroscopy, as every molecule has its own energy, but whenever there is a irradiation of electromagnetic radiation takes place on that particular molecule, the molecule gets some additional energy, and due to this absorption spectroscopy, there you can expect the different types of excitation in the molecules. What are the different types of excitation? The molecule you may observe electronic excitation. So whatever the electrons present, that may be sigma, pi, or n electrons, they get excited, and that particular will be recorded in the UV visible spectroscopy. Or you may expect vibrational excitation. So molecule will vibrate, and as a result of that the internuclear distance will change, and as a result of that there exist different excitations that may be recorded in the help of IR spectroscopy. Or there may be a rotational excitations. The molecule may change around itself in clockwise direction or in anti-clockwise direction. So there may be a rotational excitations, or there may be a spin energy state changes will be there, that may be recorded in the NMR spectroscopy. So this is a absorption phenomena results into the following types of the spectroscopy. So you may observe the different electromagnetic radiation pattern in the spectra. So how we can measure the absorption measurement? Absorption. So basically absorption is nothing but the quantitative measurement of light that is being absorbed or transmitted. So transmitted light, how can we analyze? Suppose this is a sample, and this particular sample is containing matter. It is being dissolved in the solution form. What will happen? This is the incident light. So part of the light will be absorbed and remaining light will be transmitted. Let us say IV is the transmitted light and I0 is the incident light. So how to calculate the transmittance? It is nothing but the ratio of transmitted light divided by incident light. And also the absorption. How we can calculate the absorption? It is nothing but the negative log of transmittance. And what is transmittance? Already we have calculated, I upon I0. So this is how we can calculate the absorption of any particular sample. As we can see here, it is completely dependent upon the path length. As we know that absorption can be calculated with the help of the Lambert-Beer's law. So absorption with the help of Lambert-Beer's law, it is directly proportional to the path length and concentration of that particular solution. So with the help of Lambert's and Beer's law, we can easily calculate the absorption pattern. These are the different terms which you already know, that these terms: molar absorptivity, path length. Path length is the distance of that particular cuvette. Generally it is being 1 centimeter. C is the concentration of that particular solution. And whatever the absorption will take place, that is being recorded in the form of spectra. It will be the absorbance or optical density versus the wavelength. And here, what are the spectra we get? Based upon that, we get some maximum absorption at a particular frequency, and we used to say this particular point as a lambda max or maximum wavelength, and we try to find out what is the wavelength. Suppose that particular wavelength is in between some particular region, then we used to calculate what type of electromagnetic radiation or what will be structural molecular structure will be present in that particular molecule. So this is how we can calculate the absorption. So I hope so these particular concepts are clear to you. With the help of this concept, we can understand the different type of spectroscopy techniques and how they help to understand the molecular structure of any unknown compounds or any unknown samples. So go through this particular concepts. I hope so. If you go through these particular concepts, the many of the ideas will be clear to you. Thank you very much. See you in the next session.